Okay, so now we're going to do factoring all techniques combined. So we're just going to practice factoring. All right, so I'm just going to do some problems and see how we do. So x to the fourth minus 2x squared minus 15. Okay, first of all, you look at the chart and you go, all right, well, GCF. No. Second, there are 3 terms. So that's an a equals 1 or a not equal to 1. Okay, so that's an a equals 1. All right, and then we just go look at our a equals 1 chart, or our 3-term chart factoring that. Okay, but we notice, remember, that this is half of this one gives you this one. So when we get it, so this is quadratic in form. Okay, so this is going to end up being okay, so it is definitely going to end up being x squared and an x squared for our blanks, because then x squared times x squared makes an x to the fourth. Okay, all right, so then we go blank times blank equals c, and blank plus blank equals b. All right, list our factors of 15. 1 and 15 make 14 or 16. 3 and 5 do make 2, I think. So let's see. And we want a negative 2. So that's it. So then we get plus 3 minus 5. And that's it. All right, let's do another one. X to the 6th plus 2x to the 4th minus 16x squared minus 32. All right, first of all, GCF. Nope, because this is a 1, 2, 16. So as soon as you see a 1, you know no, because 1, the only common factor of a 1 is a 1, and that's not very helpful. Okay, so moving on, it's 4 plus terms, which means grouping. So I'm going to put them in a box. X to the 6th, 2x to the 4th, negative 16x squared, negative 32. All right, common between these two. And I don't know why I start in this back one. It really does not matter. You can start here, you can start here, you can start here. Does not matter. Common between these two is negative 16. Common between these two is x to the 4th. Okay, it's the biggest that can go into both of them. So not x to the 10th. You don't add those up or anything like that. Or even x to the 6th, because a 6 can't go into a 4, but a 4 can come out of a 6. Okay? All right, now go this way. X squared. And these two, well, 2 goes into both of those. Now let's check it, because you might have your negatives messed up. X to the 6th, negative 16x squared, 2x to the 4th, negative 32. I did it. So now I have x squared plus 2 times x to the 4th minus 16. Here's something I didn't do up here, and I should have. I should have said, okay, now these are 2 terms. Do either one of these factor. These are not perfect squares, nor are they perfect cubes, so no. Okay? All right, now look at this one. This is 2 terms, but this is not a perfect square, so no. This is 2 terms. This right here, if you look at your perfect squares notes, okay, this has to be even, this has to be subtraction, and this has to be a perfect square, which it is. So this right here, should do my other color, sorry. This right here is a difference of squares. Okay, so let's do that. X to the 4th minus 16. So remember, you take the square root of x to the 4th, and we get x squared. And you take the square root of 16, not the negative, just the 16, and you get a 4. So then they factor into x squared plus 4, x squared minus 4. So now I'm going to write that over here. So now this one already factored. This one was already here. Don't forget it because it came from the very first one. Now this one, I'm replacing with these two. See, I'm crossing this out and I'm replacing it with these. So now this is x squared plus 4, x squared minus 4. All right, now look at these. That's a sum of squares. So there's a square and a sum, so nope. That's a plus. That is a perfect square, but that's a plus, so nope. This is even, this is minus, and this is a perfect square. So again, okay, so again, I have to do this. This is a difference of squares again. Okay, x squared minus 4. So we take the square root of x squared, and the square root of 4, oops, is x, is 2. So now it goes x plus 2, x minus 2. So now these two are going to replace this. So then this is, so this one's already here. This one's already here from up here. And then this one is now this. Okay, now binomial, but no squares. This is a sum, this is a sum, this is a sum, and not perfect. And this is a sum, this is a subtraction, but again, not a perfect square. So they have all been factored. And that is that.